Okay, so back to the synodic and sidereal period. Here we've got that static image again. But I want us to see this from the point of view of what this looks like when we are seeing this in the sky. And so here we have the moon taking one full orbit. It takes 27.3 days to get back round through one complete orbit. What does that mean from the point of view of things in the sky? Well, here we've got a view of the moon. We've got a view of the sky. Here you can see is Scorpio, here is Sagittarius. Here's the ecliptic, which defines where the sun is, and here's the sun. And here's the moon. You can see they're not quite lined up, we'll come back to that, but you can see that they are in the same direction. Now, after one full sidereal period, the moon has got back to the same position in the sky. It's back in Scorpio. But because that takes nearly a month, the sun has moved over to Sagittarius. So this is what we see for a sidereal period. We're back in the same position. Whereas for the synodic period, instead of just moving to the same direction in space, we have to move to the direction of the sun, and it takes a little bit longer. We have a similar situation. So here we've got that the sun and moon are lined up in Scorpio. Here we have the moon is back in Scorpio, the sun is now in Sagittarius. But the sun won't move very far in Sagittarius. You can see it's moved a little bit in the couple of days that it takes for the moon to catch up, but now they've caught up, and so this will be when you have the next new moon, and this is why it takes a couple of days longer. And you can see how much it's moved across the sky. So just to summarize what we've done so far, we've talked about the phases and how this affects moonrise and set times, and also the direction. You can tell the direction by the moon phase and the time, and then the synodic and sidereal periods.